You know that awkward moment when an A-level question pretends to be a GCSE question, but then hits you with 3 different powers of 3? Let's look at this problem. By substituting p equals 3 to the power of x, show that this equation can be rewritten in this form. And then in part B, use that idea to hence solve this equation, the original equation that we were given. So this is what we've been given. Let's see if we can find p equals 3 to the power of x hidden here. Well, I can see a 3 to the power of x here, and I can see a 3 to the power of x here. But this one has a +2, this one has a -1. How are we going to deal with that? Well, we can use this rule in reverse, where if the base numbers are the same, they're both 3, we can add the powers. Notice I'm just using that idea in reverse to split this up into 2 parts, one of which is the 3 to the power of x that we want. I can do the same thing with this, split it up into 2 parts. If we were to add the powers here, we'd get back to what we started with here. So we've found the 3 to the x here and here. What about the 9 to the power of x? How can we relate 9 back to 3? Well, you should know that 9 is 3 times 3. 9 is 3 squared. So we can replace the 9 in brackets with 3 squared. But how am I going to find a 3 to the power of x from that? Well, remember when the powers are right next door to one another, we multiply them. And it doesn't matter the order in which we multiply, so I can just swap these powers over. I've also simplified 3 squared, 3 times 3 is 9, and you should know that 3 to the power of -1 is 1 over 3 to the power of 1, so it's 1/3. Okay, so I'm going to replace all of these items highlighted in orange with p. So I've got 3p squared plus p times 9 equals 1 plus p times 1/3. I don't like the fact that I've got this fraction here of 1/3. How can I get rid of that fraction? Well, I can multiply all of these 4 things by 3. That will give me 9p squared, 27p equals 3 plus p, getting rid of the fraction. Finally, notice I need equals 0 here. So how can I make this equal 0? Well, I can subtract what we've got here to get equals 0. And we're there. We've got to the result that we wanted. Part B starts with this word hence. That's really important. It means we're going to use what we've just found to help us to answer this question. How does part B work then? Well, we knew that if p was 3 to the power of x, then this equation became this equation, which we can actually solve. We can factorize it first of all. And then we can notice that we can solve this equals 0 to get p equals 1/9. And we can solve this equals 0 to get p equals -3. Remember what p was? P was 3 to the power of x. So we're saying p, 3 to the power of x, is either 1/9 or 3 to the x is -3. But 3 to the power of x can only ever be positive. It can never be negative. So it can never equal -3. 3 to the power of x equals -3 has no solutions. So the only solution we're going to have is coming from here. Can we write 1/9 as a power of 3? Well, I think we can. We know that 3 squared is 9, so 3 to the power of -2 is going to be 1/9. What can I do from here? Well, if this equals this, note the base numbers are the same, it must be that the powers are equal too. So there we are, we've got x equals 2 as our only solution to the original equation that we had up here.